Welcome back to Worth the Effort Woodworking. Today's video is going to be a little bit different. So if you came here for some kind of project or overall lesson with a big overall theme, just come back at a later date and we'll be back on task. Today we're going to be talking more about tool maintenance. Now, personal opinion, I think probably the thickness planers and jointers are the most neglected tool in our arsenal because they are a bit intimidating to adjust and tune up. I mean, this thickness planer right here, it is spinning, at wild RPMs with 2 or 3 different blades, and those blades have to be set up dead on perfect. I mean, if one is set up a little bit higher than the other, not only is the centrifugal force offset, so it's going to have a little bit of vibration, but that one blade will be taking on a thicker cut, so there'll be more torque on one side of the circle than the other, causing even more vibration, more wear and tear on the bearings, and this thing's eventually just going to blow up on you. And if these things are kind of expensive, you don't want them to blow up. So you don't want to get that maintenance off, those adjustments off, so what do? We ignore it. We just keep shoving it through, and these things will cut with dull blades fairly easily, but eventually there's going to be so much stress on the inside, all those fears that you were worrying about by the high torque on the bearings and such, they'll happen and your machine will blow up. And plus, how many of us have put a board through and we see a little track coming down on it because the blades have a nick? Well, all that you need to do is adjust those blades. They generally have some adjustment left and right, so if you take one blade, adjust it this way, the other blade adjusted that way, the nick will offset, so the opposite blade will take off what was missed during the nick, and you'll get nice smooth boards every time. Yes, these things require a lot of adjustment if you're going to be using them reliably and you want them to last a long time. Same with the jointers. I mean, how many of us, we start out with a fence on one side cutting out and it starts getting nicked, so you keep moving it over until your whole blade is all nicked up, so no matter how much you adjust it, it won't work. And then you need to flatten something and it's just all trashed. These things require maintenance. Plus they do a lot of work. They're removing a lot of wood. That is a lot of cutting. So today we're going to be talking about adjusting these two different tools. I've done this one quite a bit. I did go ahead and buy an extra set of blades because I bought some better, I think it's better high-speed steel on them, so they'll maintain sharpness a little bit longer than the original blades, which I just would resharpen. But with these blades, they don't have an indexing pin. My previously thickness planer, right in the middle of the blade, had an indexing pin, so that you couldn't put it in wrong, but you could move it left and right. Its height adjustment was set from the factory through that indexing pin. The downside is, if you sharpened them, it would shorten the blade up so it wouldn't cut as well. So you basically had to replace the blades when they had those indexing pins. Pluses and minuses, easier adjustment or $30 to $60 for replacement blades. Now, the jointer I set up with just a straight edge. Now I'll show you that technique later on. The thickness planer, they generally require some kind of setup tool, and I bought this one a few months ago from a retired shop teacher, and on all vintage tools, I think this one is early 90s, maybe late 80s or something like that. Guess what's missing? He couldn't find the little adjustment tool, so I bought, they call it a mini planer pal, just a little inexpensive magnets that you're designed to set up on there. And the thing it will do is it will set the blades up equal distance on both sides. This one only uses 2 blades. Now the blades that they have on it have an edge on both sides of it, which I have a feeling this might be the original set. So if it is, I'm just going to reverse the blades and hold on to the fresh set. But the key thing why I wanted to film this is I've never worked on this machine. It is a new machine to me, and it is so old it predates the internet, so there's no instruction manuals online. So I'm going to have to figure this out on my own as I take it apart. And that's something that I want a lot of people to understand. It's something that my students struggle with because I taught computer science and webmastering and stuff like that, and they were intimidating. What they didn't realize is man-made stuff is designed to be worked on by men and women. I mean, how stupid would it be for Delta to manufacture a thickness planer where a normal maintenance item like replacing and sharpening blades couldn't be done by the average person? We would spend all this money on these devices, use them for 6 weeks, they get dull, and then what? Buy a whole new one? No. They want you to be able to use it. They want to make it easy for you to use it so that you'll get good value out of it and they can sell you more equipment at a later date. It would be bad PR for them to make it so you couldn't work on it. Same with computer languages. The guys that designed HTML, Perl, Java, all those kind of stuff, they wanted people to be able to program with it. They wanted people to be able to learn it easily. So don't be intimidated by it. Just take your time, be patient, think it through, use a little common sense, and we'll get through it. So let's examine this as we go along, and I want you to decide if I'm doing it right or if you'd make other changes based on your common sense. And leave comments in the bottom below to help other people out if you have some tips or techniques. So, today, let's get our hands greasy. Okay, so let's do a quick walk around with it. Before I work on it, I actually put the plug in my hand so I know that it's not unplugged. You don't want to unplug something, then go out for lunch and come back in and find out in the middle of working on it that somebody came around and saw the plug unplugged and plugged it in for you, doing you a good favor. Hold it in your hand, make sure it's done, and then come over and flip the switch on and off a few times. Some machines have capacitors that might rotate the blade a little bit if they get discharged. So just be sure everything's undone and it doesn't turn on. Then coming around this particular model, of course, you have the adjustment like everything else. It doesn't have a lock on the other side like my old one, but it looks to me like we got a big old motor right there, a belt right here. This belt cover is kind of not great. Doesn't really cover much. It's hardened plastic that used to be flexible, but now it's really hard. Coming around the other side, no adjustments. Here's the chute, and if you look up inside the chute, you can actually see the blade. Right there is the blade. It might be too dark to see. So based on that, we know the first thing we need to do is remove this shield so that we can get to the blade, and it looks like they just put 2 screws there. Fairly common sense. Let's get those out. Oh, I do suggest you get some kind of magnetic thing to hold all your loose parts so you don't lose anything. So let's take a look at what we got. Right here's the blade, and there are 2 blades in there. There's a bar underneath it, and there's these screws. It looks like you tighten the screws up, that nut pushes against this thing, and that's what locks the blade onto the little spinny thingamabob. I don't know what you call those. So, common sense would say, loosen these up, replace the blade, and tighten them back up. But then we have to get this adjusted. So let's try that. Kind of weird, I went to my toolbox and got wrenches for these. I got a 1/4 inch here, which is too small, and a 5/16, which is just a tad bit too, it works, but it's kind of loose, and there's no metrics in between them. I think this is all imperial, but oh well. So we're going to loosen them up, and I tend to loosen from the sides in. It's just what I learned as working on motorcycles. Okay, last one. Let's see if the blade is loose. Yep. Just slides out. And doesn't look like the other side's been used. So this is the original set of blades, and he's never had it reversed to sharpen it. So I'm just going to slide them in and save those set I just bought for myself. And it appears to be a spring in there. See how it's springing back up? So that must be to help set the tool, because basically you could set the whatever gauge you want on it, and it is going to push up against that gauge, and you just tighten it up. So you just have to keep the gauge on there. Isn't that clever? They're making it easy on us. So this is the jig I bought, and the idea is you got the circle right there, and the jig sits on top of it. There's a little stop block, and then a pin that registers in the front so that you can register the same on both sides. Seems fairly simple. So there's a pin that registers on front. That's a little metal magnet, and these sit on the circle. Let's go for it. So I have this little registration pin that's going to rest up against there. We got 4 magnets to hold it on, so let's see if it works. Okay, I got the back magnet on. It goes forward, registers there, and I rotate it back until that pin locks on. Or maybe I can come forward and feel the pin. Yeah, there we go. Locks down. Let me take a look at it. Looks pretty good. Let's try the other side now. Okay. Let it go down. Magnets, move it forward until that registration pin just goes right over and locks on the edge. Which is right there. Push the blade down. Yep, it comes back up. Sets it up. Make sure it's somewhat centered on this roller thing. That'll give me, I can adjust it this way once and then that way once if I ever get nicked. And now to tighten it up. And I'm going to reverse the tightening order. I'm tightening in the middle. That way it kind of stretches it out so there's never going to be any binding in there. I would say that's a perfect 60 foot-pounds of pressure. Finger gauge. Then after you got everything torqued down, go back one more time just to make sure nothing loosened up. Now to the other side, rinse and repeat. Okay, now to just check my work, I'm visually looking at the end of the bevel to this thing right here, and it looks to be about equal on both sides. And obviously that's not a micrometer meter, but it's close enough that I'm confident that if I just put a board through this, it's not going to blow up on me. And we'll test it out in a second. Now just to reassemble the dust shroud, and we are done. Not to make you think that the engineers are really smart, but see this screw right here? There's no way to get it into the screw thing with this piece down. You actually have to lift it up so you can get clearance to put it in, which is kind of stupid. They could have relocated that easily. Ah! Finally! So let's test it out and see how we did. look at that. I don't see any grooving or something like that, as if one blade was higher than the other. I think we did pretty good. Now on to the joiner. Okay, my jointer is set up in a very similar fashion as that thickness planer, in that I have a blade that rests against the base. The base is the drum. Then I have a bar that pressures the blade against the base. And then I have these nuts, there are 4 of them, that tighten the bar against the blade against the base. Now, I do know from past experience that this blade is not spring loaded, so it does not push back. How you set the depth of that is it includes 2 hex keys that as you rotate them, they raise or lower, and the blade sits on that hex key. And then what you do is I have taken a straight edge, run it off of the outfeed side of the table, because that's what I want it to be planar with, and basically I would rotate this drum until the ruler did not move. Right after it did not move, that told me that the blade was just ever so slightly touching it, but not raising it up a little bit. And I would do that adjusting this hex key. And once I got it dead set, I would tighten this far side nut up. Then I would come to the other side and do the same procedure, raising it up, and then tighten that up. Then I would come to the middle, check it, and tighten all 4. And then I would come back over, I would spin it, and if it moved, basically I loosened everything up and started all over. It's a very time-consuming process. But I'm going to experiment with those new little thingamabobs I just bought to see if I can make it any easier. What I think is going to happen is they're going to set the blade up equal, but it's going to be different here, so I'm going to have to raise up my outfeed table to match those up by doing this straight edge trick. But since all the mechanicals are the same, there's no need for me to shoot another video of me tightening and loosening bolts. Well, I hope you enjoyed this video. I know it's something different from what we normally do, but don't worry, our next video will be back into the woodworking area. But maintaining your tools is part of woodworking, just not as glamorous. If you do enjoy our efforts, please consider liking, favoriting, subscribing, maybe leaving a comment down below. And if you'd like to support us a little bit more, allowing us to buy materials to make things and stuff like that, visit our website, wortheffort.com, where we have lots of cool items for sale. For example, this winged, carved, scorched pecan bowl, and lots of other boxes, containers, and that kind of stuff. Plus, I have a whole line of custom t-shirt designs that really does help us support the school, and it's not much of a capital investment for y'all. Plus, there's other ways if you just want to donate something to help patronize us. All that's available on our website, wortheffort.com. Plus, I have a pretty interesting blog there, too. Well, I hope you enjoyed this, and remember, it is always worth the effort to learn, create, and share with others. Y'all be safe and have fun.